Astronomers have realized that big galaxies take star-forming gas from their smaller neighboring galaxies. Large galaxies are known to strip the gas that occupies the space between the stars of smaller satellite galaxies. In a recently published research paper, astronomers have discovered that these small satellite galaxies also contain less molecular gas at their centers. Molecular gas is found in giant clouds in the centers of galaxies and is the building material for new stars. According to a prominent member of the research team, this study provides new systematic evidence that small galaxies everywhere lose some of their molecular gas when they get close to a larger galaxy and its surrounding hot gas halo. Gas is the lifeblood of a galaxy. Continuing to acquire gas is how galaxies grow and form stars. Without this process, galaxies stagnate. They have been aware for a long time that large galaxies strip atomic gas from the outskirts of small galaxies, but until recently it had not been tested with molecular gas in the same detail. Most galaxies have friends, therefore, galaxies do not typically live in isolation. And when a galaxy moves through the hot intergalactic medium or galaxy halo, some of the cool gas in the galaxy is stripped away. This fast-acting process is known as ram pressure stripping. The research was a global collaboration involving scientists and researchers from the University of Maryland, Max Planck Institute for Astronomy, the University of Heidelberg, Harvard-Smithsonian Center for Astrophysics, the University of Bologna, and the Massachusetts Institute of Technology. Molecular gas is very difficult to detect directly. The research team took a state-of-the-art cosmological simulation and made direct predictions for the amount of atomic and molecular gas that should be observed by specific surveys on the Arecibo telescope in Puerto Rico and the IRAM 30-meter telescope in Spain. After that, they took the actual observations from the telescopes and compared them to their original predictions. The two were remarkably close. It has also been mentioned that based on a survey of atomic gas, the IRAM 30-meter telescope observed the molecular gas in more than 500 galaxies. These are the deepest observations and largest sample of atomic and molecular gas in the local universe. That is the reason for it being the best sample to use for this analysis. The team's discovery fits with previous evidence which suggested that satellite galaxies have lower star formation rates. According to another member of the team, stripped gas initially goes into the space around the larger galaxy. That may end up eventually raining down onto the bigger galaxy, or it might end up just staying out in its surroundings. In most cases, the little galaxy is doomed to merge with the larger galaxy eventually. Often they only survive for 1 or 2 billion years, and then they'll end up merging with the central galaxy. Therefore, it affects how much gas they've got by the time they merge, which then will affect the evolution of the larger system as well. Once galaxies get large enough, they start to rely on getting more matter from the surrounding smaller galaxies. In an image returned by the NASA ESA Hubble Space Telescope, it provides a focused image named UGC 695, which is located approximately 30 million light years away within the constellation Cetus, or the Sea Monster, also known as the Whale. A bounty of diverse background galaxies is also visible from that image. UG 695 is a low surface brightness galaxy. These galaxies are so faint that their brightness is less than the background brightness of Earth's atmosphere, which makes them tricky and difficult to observe. This low brightness is as a result of the relatively small number of stars within them. Most of the normal or baronic matter in these galaxies exists in the center of huge clouds of gas and dust. The stars are also distributed over a relatively large area. LSB galaxies, like dwarf galaxies, have a high fraction of dark matter relative to the number of stars they contain. Astronomers will debate about how LSB galaxies formed in the first place. The absorption of one galaxy into another, or the merger thereof, is sometimes quite puzzling for astronomers. Across the universe, galaxies are being merged with others, and it is a question that puzzles many scientists. Some of these galaxies are even disappearing. According to new research that was published, the study reveals that a phenomenon called ram pressure stripping is more prevalent than previously thought. It drives gas from galaxies and sends them to an early passing by depriving them of the material to make new stars. The study of 11,000 galaxies shows that their gas, which is the lifeblood for star formation, is being stripped away on a widespread scale throughout the local universe. One person attempted to state that galaxies are embedded in clouds of dark matter that they call dark matter halos. Dark matter is a mysterious material that, despite being visible, accounts for roughly 27% of our universe, while ordinary matter makes up just 5%. The remaining 60% is dark energy. During their lifetimes, galaxies can inhabit halos of different sizes, ranging from masses typical of our own Milky Way to halos thousands of times more massive. As galaxies fall through these larger halos, the superheated intergalactic plasma between them removes their gas in a fast-acting process called ram pressure stripping. You can think of this like a giant cosmic broom that comes through and physically sweeps the gas from the galaxies. It dictates the life of the galaxy because the existing stars would cool off and grow old. If you remove the fuel for star formation, then you effectively take the life of the galaxy and turn it into an object that is without life.